So, hello, and welcome to the second part of Raymarching in TouchDesigner tutorial. Last time we talked about geometry and different ways of creating and defining it, and we also talked a bit about Raymarching itself, how it works, and how it's different from normal rendering. And this time we will talk about lighting and different ways for creating lights and colors as well, because lights and colors are very close together. This particular file is on my GitHub Raymarching in TouchDesigner, and it's called tutorial part 2. I will upload it right after I finish recording it. So let's dive in, and let's dive in a super simple basic light setup without any color. Actually, it's even more simpler than we have before, because last time we stopped at situation like this, where we have something like a phone model. We have an ambient, diffuse, and specular light, and we also have a light color for creating lights and even a little bit of shading. However, we don't have the real shadows and ambient occlusion. Okay, let's open our code. Okay, and go into let me first explain you a bit what's going on here. When we looking at lights, it's nice to have this complex geometry with different foldings. It's really great to represent how light works, how shadow works. But what is it? How I created it? What I used here in geometry is a TouchDesigner built-in function called TD Noise. You could read about it on wiki. So you feed vec2, vec3, or vec4, and it gives you a float with noise, with result between -1 and 1. And next, if you create a sphere, and then if you calculate the intersection between the noise is on the whole space and the sphere, you'll get something like this. And the noise works a little bit like a noise stop in TouchDesigner. You need to have at least one dynamic variable in it. So here I feed vec4. This 3 is static, is a position, and this is the time, which in a way is similar. Well, it's absolutely similar as where is it? Here is it. As a me times seconds, which is kind of same as abs times seconds, but it's how to say? Abs times seconds is absolute time, world time, and me times seconds is a timeline based. Okay. And for example, if I change it to vec3 and delete this dynamic variable, I'll get a static noise. Everything is running, but noise is static. And of course, dynamic noise is vec4 looks better. But that's enough about geometry. Let's go into light. How the light is created. Okay. The output of a GLSL called frag color. Let's look at frag color. If a distance is more than maximum distance, we set here. Then we return a transparent background because it means that we don't hit anything. And here our transparent background. Boring, boring. But what interesting is that what if we hit anything? What if we hit something? Then we execute the lighting function and pass a diffuse color and the point um, position. Our position. Okay, let's go and find this lighting function. Okay, here is it. What's going on? Let's try to understand. Okay, let me move it here so it's visible and the code visible as well. And I will simplify it a lot like this. Yeah. First of all, uh, Raymarching function gives us a result. Did we hit some surface or not? And the simplest situation, which is more or less similar to a constant matte in TouchDesigner, is to say if we hit something, just color it all in one color. Here is a black color because it's vec-free 0, so it means 0 red, 0 green, 0 blue. You can change it to, for example, 0 and 0, and you get the red one. Okay, but of course it's boring, so let's add something. What's going on now? Now we took the Ulight one color, which is somewhere here, white color, and multiplied by some diffuse color and a dot product of light position and normals, which in a way is a kind of super simple font model. We know our normals, the light goes from this direction, so we do our coloring based on the normals and the light position and the light color, of course. This already pretty looks kind of nice, especially if we choose something better, something more colorful, something like this, and some if it's green with oops, no, I don't know. Yeah, okay, good enough, good enough, good enough. The next one, let's multiply it by something called square root of Oc, which is Ambient Occlusion. And let me show it to you. Without Ambient Occlusion. Okay, let me pause because it would be more easy to see. With Ambient Occlusion. Without and with Ambient Occlusion. As you can see, it gives a better shading in some foldings because Ambient Occlusion is about the light inside some. It's an object that creates a shadow on itself in a way. And what's good about ambient occlusion in Raymarching, it's pretty cheap computationally, especially if you compare it with how it's called. It's called SSRO, Screen Space Ambient Occlusion in TouchDesigner. If you used it in rendering, it can be pretty slow. And here we run it 60 FPS, no problem. Ambient occlusion doesn't change anything almost. How it calls a function called ambient occlusion. Where is it? It asks for position and normals, and there is some variables. Some variables you could look here on vector to page. So I wouldn't speak much about it. You can explore it itself. The only hint I can give to you is that if you don't know how if you don't know which numbers you could change, for example, does it matter? Does this for column matter or not? You can always look. Okay, we have UAO, go up, UAO. Okay, it's vec free, so we have 3 parameters. So you can change these 3 parameters and see what's going on. Right. Ambient occlusion. Good boy. Next. And next we calculate the shadows. Shadows. Real shadows. Shadows from light. And we need to enable all 3 of these strings. And move here. As you can see, this shadow appears. Again, I can do this, no shadows. Shadows calculated in soft shadow function, and if you're curious about how it works, you can check this link from the great Inigo Quiles. And here is a big article about soft shadows, some crazy words like penumbra, I don't know what does it mean, and some math, really great but complicated stuff. So it's up to you. Do you want to understand it or not? It doesn't matter actually, because it works. You can just use it as you want. Okay, I don't like this color. Let's put it black back to the grayscale. Alright. So, and this is our basic setup. So we calculate color as a diffuse color from the light source, then we multiply by square root of ambient occlusion, mix it with a shadow, and return it. And after we return it, we just output it. So if our Raymarching function says that we didn't hit anything, we return the transparent, and if we hit something, it will calculate all the lights. I hope it was understandable. Sorry for my English, of course it's not a native language, but I hope my English understandable as well as this code. Let's move on into our next component. I will explain this 3 or 4 in more details, and this more complex I just show it to you and say okay, you can experiment with it. Alright, now we have a standard light setup. Why it's standard? Because it's the same that we have last time: ambient, diffuse, specular, and the light color. So how it's changed from basic setup? Let's dive in. Alright. Instead of lighting function, we have a different name, fog illumination, and we have a lot of arguments: ambient, diffuse, specular, shine, position, and eye, which means camera direction. It's set here. You can move camera. Yeah, yeah, you can move camera. All right. So, what is fog illumination? Let's look at it. By the way, in Sublime editor, if you select the name of a function, you can see here is a highlighted, and you can click. Okay, here's our fog illumination. Here you can check, you can read description about fog. What is fog in Wikipedia, or I don't know, probably there is some great tutorials on YouTube about what is fog and how it works. But again, you don't necessarily need to understand everything. You can just try, and that's good. Okay, what we have here? It's more or less the same. We have ambient light and what is Ka and ambient color, multiply it, and then we run a different function. And why is that? And this function looks pretty similar to what we have here. We have shadows and ambient occlusion. Ambient occlusion and oh no, shadows here. Okay, ambient occlusion. Why is it? Why do we need the second light function? Because here we have only one light, and if we have only one light, we can describe everything here in one function. But what if we would like to have 2 lights or 3 lights? Then it's a good idea to have a separate function which you could execute for every light source. So you have one function called fog illumination for describing ambient light, overall ambient color, and then you run special function for every light source, and then you add shadows. Let me show you a second light. I will enable second light. Does it change? It should change. How can I? Okay, I can multiply it by 5 to make it really brighten. Okay, I can multiply it by 50. No. Light position, light color. Okay. I need also this. Okay, and here's our second light, which also contributes. Okay, 50 is too much. And we have, okay. Now we have 2 lights. Alright. But what if we want more than 2 colors? What if we want 10 colors? 10, sorry, not colors, but light sources. Of course, you can do the same and write the same code again and again and again, but it's not a good idea. It's too long to copy paste everything. So what could you do? Of course, you can use a for loop or while loop. And that's exactly what we have in our third. By the way, if you wonder why do I switch on and off, it's because some of this is very heavy, and if I enable everything, well, likely TouchDesigner didn't crash, but my FPS drops, so that's why I prefer to switch on and off. So, our third component is a light array setup. And here I have a noise function, and I have 5 lights, but I can use 10 lights. And they are still pretty good with FPS, especially because I'm recording right now on the same graphic cards. So 10 lights plus Full HD recording, well, pretty good. But it's my graphic card found become noisy, so let me put it back to 5. Back to 5. Why is it all red? Why is it's just, it doesn't matter. And from noise function, I do both position for the lights with some method, like for example, Y position is positive, so it doesn't go below the surface of our plane. I can move it closer. I like to use my top. Okay, or I can move. It's a really nice way to move and change and noise and basically any top. In a way, it's a complementary to the level, in a way. And it gives us position, and the second part is for the color. Okay, but let's go into the code itself. What do we have here? Dun, 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 dun. Okay, the same function for an elimination, and the same, and here's our for loop, and here's example how to use a texel fetch buffer to feed the values from tops or chops. As you probably remember, last time and last tutorial we have the same template array with where the position of geometry was defined in the same way. Here's the array. You need to set this as a texture buffer, define it in the beginning of a code. Here's uniform sample buffer, light position, light colors, and you calculate this second function font contribute for light for every of our 5 lights. Another thing, this in GitHub repository, I put the version 2 of our templates of array template and basic template, and how it different from the version 1. It's different. I add shadows and ambient occlusion because I think in many situations you like to have it, but sometimes you don't need shadows and ambient occlusion, and then you can use the first version without it. Alright, yeah, I think that's it for the third one as well. Okay, if else coloring. What if we want to make different colors for different objects in the scene? Because our Raymarcher, okay, I show here. Our Raymarching function is a float, and it just says us how far we are from some surface, did we hit it or not. It doesn't give us any information about what object do we hit. So we need to add this information somehow. And a simple way to do it is use conditions. Let me show you. Uh, by the way, it's again a bit simplified version because it's again only diffuse and light color as we have in our first component. But if you want, you can add ambient and specular as well. It could be your homework for this part. And it's pretty easy. I would say it's level 1 homework. And later I will give you level 2, level 3 homeworks out of, I know, out of 5 levels of difficulty. Okay. Where am I? Where am I? Lighting. 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 And we have here's our condition. And in our condition we have some strange thing. Dist Y. What is dist Y? Is it dist fun? Is it dist? Okay. Dist is something we pass to our function. What did we pass? We passed dist. What is dist? Dist is the shortest distance to the surface, so it's our Raymarching. But it vec2. Why is it? We have flow dist all the time before that. Because it's our Raymarching, which just says us how far we are from the object. And now we have vec2, so it gives us two numbers. So let's look at this. Distance. Okay, and the distance functions sorry, sometimes I'm a bit stuck because I need to remember English words and remember what does it mean in this code and everything. And I don't have any script, I just record it. Okay, here in this function, vector dist is seen as def function, which also vec2. Why? Oh, and here as def we have float as well, because we have a float for plane, we have function for plane, for sphere, for noise, and so on. And here we have vec2 for plane, vec2 for noise. The first part is the same as here. So the x component of a vec2, or s component, or r component, it doesn't matter. In GLSL you can use different, I can't remember how it calls, swizzles probably, not sure. Okay, you can use RGBA, you can use XYZW, or you can use STPQ probably, not sure. Anyway, what matters if it doesn't, for example, if you use RGBA, it doesn't matter that you're talking about color. You can use RGB as a space. Alright, doesn't matter, right? And the second number is just 1, which says, so in a way we say for the plane, the first number will say how far we are from the plane, and the second all the time will be set as 1. For our noise, sphere noise, this one, which is intersection between the sphere and noise, we set it to 2, and for second sphere as 3. So, and we also need to return it in a different way because in normal Raymarching we just return the minimum, so the closest object, and now we also need to return which one object is it. So sorry, I have some notifications going on, doesn't matter. So how it works, we compare position and how to put it. Okay, for example, we stuck in this point, and this function, and in this point it means that we are, for example, 0.1 unit from this sphere, 0.5 units from the plane, and I don't know, 1 unit from a green sphere. So we just say if we closer to the, if our distance to a sphere noise is less than our distance to the plane, then we should return ID for our sphere noise. And else if our plane is closer, so if we I don't know, stuck somewhere over here, then we return ID for the plane, and then we do a second condition, and the same for the second sphere. I hope it's understandable in a way. It's not the best way to do coloring, but it's really simple, and it doesn't need to change our coding template. But if you want something more complicated and more colors, you probably would need to use a different code, like here on Shade Editor. Here's a nice example of a lot of colors of different spheres, but as you can see, it's a really different code, and I don't want to sorry again, forget this word. Okay, I don't want to make any troubles for you. I don't want you to understand every different code, every different Raymarching technique. If you need this, you can do it by yourself, and it would be the homework level 2 to implement it in TouchDesigner. It's totally doable. I did it myself, and probably I'll share it with my patrons on Patreon, and you can support me as well if you find it helpful, or you can implement it by yourself. And here we use some not we here Pete use something called struct, which is element of GLSL. Okay, doesn't matter. Doesn't matter. Let's move on. Oh, no, not move on. Not move on yet, because here we have our 3 colors. Yeah, so we can set the colors for the plane, for the and for the sphere, and of course it also would be affected by the diffuse and the light color. So it's not the same, the plane not the same color as this one, because we also have a diffuse and light color component. But sometimes you don't want to use specific colors, you just need different colors. Then you can use generative colors. What is that? Where is my... Okay, try to comment lines, this one, and uncomment this one. And here our different idea of how to make 3 different colors. How it works? We just have some random color and multiply it by some dynamic variable. In this case, I multiplied by the sine function of u time, which is our time in seconds, and our distance. So our distance point y is our ID. So for every object, this float would be different, because, for example, I don't know. Okay, here's our u time equals 1, so it would be 0.3, and then for ID number 1, which is what's ID number 1? ID number 1 for the plane would be 0.3 plus 1, for the sphere plus 2, and for the second sphere is plus 3. And of course the sinus function for different numbers, for different degrees would be different, and because of that, when you multiply it by some random color, the colors would be different as well. So you have generative colors. It's another approach. And of course you can use not u time, but some different dynamic variables. For example, you can, I don't know, run music and calculate some, I don't know, music volume or whatever. Doesn't matter. Anyway, let's move on. And this one is a bit, I'm not happy about it. It's the same idea, but with textures instead of colors. Or actually we have a color for the object 1, our plane, and the textures for object 2 and object 3. And it's made in a way similar, but you can look and explore by yourself how to feed the texture, and bump mapping into Raymarching. I wouldn't explain it to you because honestly I don't understand it fully by myself, because all of that function I just found some nice shader on shader toy and then rewrite it to make it more or less similar to our code template. And why don't I very happy about it is because for example, in SOP texture we have a lot of parameters, how to project our texture and how to scale our texture, offset it, rotate it, and so on. While here we don't have much parameters and I don't know how to do it. So it's time for homework now, level 3. If you're really smart, you can try to implement some ways to control this texture and how it's applied to the object. But you still can experiment with the textures itself and create different looks. Yeah. So I'm not happy without it, but it's good to have it in this color and light tutorial, probably. And now we move not to the 6th component, but to the 7 and 8 because I wanted to do it. I will return to the 6 a bit later. First of all, reflection. Ooh, something very different here. Let me pause for a moment. And let's think. Reflection. If we have a reflective surface, we need something to reflect. And before that, we have just an absolutely empty space and some geometry inside it. So we don't have anything to. We don't have environment. We don't have environment. We don't have anything around us. And we don't have anything to reflect. But we need it. Like this environment light in a normal, in a standard rendering technique. So we add a cube map. Cube map is a way to create this environment. And for cube map, you can use different ways to create it. The simplest one is just to Google in the internet, Google, and find the real cube map that looks like this vertical crosses. It's kind of easy to find. And if you find it, you just feed it into cube map top, and then you feed it into to our GLSL. And when we have cube mapping, where we are. Oh yeah, code. The code itself is also different because of a very different setup. I can't make it the same structure as other code because it's different. because it's need a reflection, and for reflection we need a little bit different approach to Raymarching. We need some for loop for number of reflection. So the code is a bit different. Just deal with it. Deal with it by yourself. Okay. And here's our texture. The other way, if I would say that nowadays this vertical crosses is not so popular. Usually you found something like this, and this is, by the way, is a file from the TouchDesigner samples folder. It's called the Palace of Fine Arts, and this also environment mapping, but in different format, so you need to convert it. And for converting, you're using a projection top. And in projection top, you choose input, which in our case a key rectangular, and then convert it to cube mapping. And another approach would be creating cube map by yourself. You need to look at help with it. Help. Here's a cube map. So we need to feed 6 input, which correspond to +6, -6, +y, -y, +z, -z. So it's right, left, up, down, and forth, back. and here I feed it. And if I switch to input number 2, we get this a bit boring setup. Okay, reflections. What is reflections? What's the difference here? Let's set number this variable called uNumRef, which is number of reflection, to 0. We have nothing. We have just our color, simple color, because it's the same as having no font in the first basic setup. If I set reflection to 1, we have our, okay, let me just switch it back to 0. Then we reflect our surrounding, but don't reflect of the reflection. And instead of reflect in places where you need to have a reflection of the reflection, is again this color. And if you set number reflection to 2, so we have now reflection of the reflection. With number 3, we have reflection of the reflection of the reflection, and so on and so on. And how it's done? It's done here in this loop. We start from -1, and and we calculate our reflection. And after we calculate our reflection, again, I don't really understand this math. Well, I understand it a bit, but not as good as I hope I would it in some future. And after we calculated reflection, we redefine our color. So we put our reflection into our color of object. And then we give new direction and a new position. And we did it because we don't want to calculate to Raymarch for every, I don't know, 5 reflection the whole scene. For the second pass, we need to calculate Raymarching only on this. We need to calculate it only here on where we don't calculate anything yet. And then we need to calculate only these areas, and every time we need to calculate to do less and less calculation. And what it gives us the opportunity to really set it really high, like 30 reflections. And we're still pretty good in FPS because we calculate reflection only where it's needed. So it's more about the look. I don't particularly like this messy, noisy look when we have a lot of reflection. So it's not a good idea to set it as high as possible. Usually the number between 4 and 7 is a very good. But of course it depends on your scene. I set it to 5. When we're working with reflection, our minimum distance also really matters. What is minimum distance? Is you mean dist. Where is our measure? Here. Set if our distance is less than our minus, when our minimum distance, we just break. In other words, sometimes when you don't hit the surface, okay, Okay, sorry, I'll pause. I'll pause a bit. Okay, I'm back, and this is a picture I want you to show you. This is, let's say, it's two-dimensional Raymarching, and we do marching step by step by step by step until we hit the surface of our object. In this case, two-dimensional, but in three-dimension it's absolutely the same. If we hit the object, we do our coloring. But sometimes, especially when we use a noise function or sinuses or something else, our distance between our camera and the surface of an object could be irrational number, and we never hit the surface itself. We always a tiny, 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 tiny amount of distance from the object. So that's why we have this minimum distance, which means that when we are 0.001 unit from the surface, when our Marchi said that we are 0.001 unit or less, we say, okay, let's just assume that it's a surface already, and let's just do the coloring like it's a surface, like the situation when distance equals 0. And usually it's good to have this number quite low. But sometimes when we work with reflections and refractions, it's interesting to experiment. For example, if I set it like this, we have a little bit different view, and we can experiment. Okay, it's too much, and you can try to find you can try to different values here. And we also have another parameter, the U minimum distance for reflection, which also gives us it's almost the same but for reflection, and it's interestingly for big values like this one. Oops, we can have really strange looking stuff. It's the same but only for reflection, and if we almost like 2 units from a surface object, we already give up and do a reflection like we already on the object, and this gives us a different look. So experiment with this as well. 0 part, but most of the cases it should be quite low. Okay, that's probably it for the oh no, one more. If you're using a non-commercial version of TouchDesigner, then you have a low resolution for environment mapping. This means that our cube mapping would be quite low resolution, which gives us here you can see how it's all pixelated. So how to deal with it? One way is to use commercial version of TouchDesigner, and another version is to use a rendering. To do a rendering, but if you render something uh, normally, if normal geo, light, and stuff, and when you have a render, you have here in render mode, you have this cube map. So you can render some of a scene by yourself. And I'll show it to you in other component a bit later. Okay, let's move on to refraction. Refraction is kind of same as reflection, but we don't we not only reflect something, but we also do some um, modification of reflection, some changes. So it looks like distorted, so the reflection would be distorted. And we also have a little bit of transparency here. It's maybe it's not very visible, but okay, doesn't matter. Um, Here the code become even more difficult, and this code I don't understand at all. Absolutely. But I still include it because I like this reflection. And you have this, oh sorry, a refraction. It should be, it's not reflection already, it's refraction. Refraction. Okay, refraction. Yes. So experiment with refraction parameters, and maybe it will be helpful for you as well. And one more thing, you could use the same environment for the both inputs, like here, and it gives us a clear and refraction. But if you think about it, usually, for example, if it would be a glassy sphere or maybe a soap bubble, it usually distorts the colors as well. So what you can do is you can use the same file, add some blur, do some color adjustments, so it would be more rainbowy, like this soapy bubble, and it gives us a more interesting look, I guess. Okay, so what's next? Render combine. Render combine. Oh, woo. Okay, this is a way of combining our classic TouchDesigner rendering with camera, light, render, and geometry, and our Raymarching in one scene. But first of all, let me show you this cube mapping. The cube mapping I tell you about is you can create, for example, a sphere by doing some facets, some noise, some coloring, and render it as a cube map. And now the resolution is quite good, and you can use it as a cube mapping as well. This particular technique I saw in a really nice toolkit from who is that? From Patrick. He Lessig, called TD Raymarch Toolkit. Just I really recommend it to try it, to play with it. It's also Raymarching in TouchDesigner, but completely different approach. What he did here is Raymarching. You create Raymarching scene from components like normally in TouchDesigner. Just download it and look at this really great project. Really recommend you. And he uses the rendering and Raymarching as well. So I did it too. How it works? We are rendering this blobby thing. This sphere, we don't render the sphere. This sphere is only for displaying, and it's on the same spot as our sphere here. We feed the camera positions, and the camera angle to our Raymarching. Here we feed diffuse both to the font for our rendering and to the our Raymarching, and we feed the light color and light position also both the same for render and for Raymarching. So we have a similar setup, and we not only rendering it, but we also use a depth top from our render, and set it as a camera space. If it looks like this, it gives you a depth, a distance to this blobby thing, and we feed it into our Raymarching. We feed it into our Raymarching, and where is it? It should be somewhere over here. Over here. Okay, here we calculate in our cube mapping, because we also rendering our cube mapping for this gives us our environment for the camera, for the given camera position and camera direction, which calculated also in Raymarching loop, but in separate buffer, and I explain the buffer situation a bit later. Here, instead of using max distance from the Raymarching parameters, here, okay, let me remind you what is max distance. If we do Raymarching function more and more and more, and if we reach 100 units, then our Raymarching function will give up and say, okay, probably there is nothing there. Because if for 100 or maybe for the 1,000 units there is nothing and we didn't hit anything, probably we just output the transparent background. But now we also have our render depth from this top, and if our rendered object is close enough, like here, okay, let me move it a little bit, like here, so it's closer to the camera than our object. We also want to render it as a transparent, so the rendered with the same color as our max distance. So we redefine our max distance. We choose a minimum between this value and our render depth, and color in it. And I can show it to you probably. Okay, it's the same color as our background, and in our case it should be transparent. So it's in a way it's like a matting, doing matte, and when we composite it, we have a right looking scene. The object on front is on front, the object on back is on back, everything is nice. Let me try to change the noise to show you. Okay, it should be probably 0.5. Yeah, well, maybe 1.5. So even when our second object is on the back, you can still see it in the holes of our noise sphere. It's really great. And we add our cube mapping here as well, and we have our scene. And of course, if you don't like this cube mapping, you can use another one. It's the same. So what this color buffer, this buffer is done is doing is calculating the world direction, which is direction from the camera to the outside world, and it gives us a position where camera looking at if it wasn't any object. Okay, so and it can be helpful in many situations when you want to have a classical rendering, and you can of course use instancing, and you can use anything you want from the classic rendering approach in TouchDesigner, and it combined with this nice smooth looking Raymarching. Very good, very good. And the last one, which I'm really proud of, it's a buffer compositing, because if almost everything before that you can find in Shader and learn by having a look at Shader code. This one you couldn't find on Shader because it uses a TouchDesigner, well, not TouchDesigner, GLSL function, which Shader doesn't have, which calls it's called color buffers. What is color buffers? Most of the time, in GLSL, okay, let me stop camera moving because it distracted me. Okay, let's make stable camera. Okay, that's better, and gets rid of this noisy background as well. Okay, usually in GLSL we calculate everything we need in GLSL and output in the top, but sometimes what we want is to do several different calculations and put it in different outputs. For example, we can output the whole scene in one top, GLSL top, and the same scene without shading, for example, on another top, and the shading without the colors in next top, and so on, so on, so on. How to do it? First of all, you need to set on the GLSL top parameters the number of color buffers. By default is 1, I suppose. Yeah, by default is 1, and you need to set it higher. And if you set it really high, it gives you a warning, and in my case it says your video card only supports 8 color buffers, so I can give only 8 outputs maximum. So here's 8, but most of the time I don't need the 8. Usually I need only 1. Okay, next you need to usually what you're doing is where is our basic too much code. Usually you have only one string, this layout in location 0 output frag color. But if you want to use multiply buffers, it just say something location 0 output frag color 0 1 2 3. Of course it shouldn't be these particular names. You could name it as, I don't know, color, position, X, Y, Z, Y, something, and so on. But I make it simple. I have 6 buffers and 6 outputs. And our classical default color buffer is the same. But let's say we want, for example, output. Which one is it? That's color buffer number 3, so it should be. Yeah, it's probably frag color 2. It's here. Oh no, it's color 3. Not sure. Let's find it. Yeah, here. Here we output, for example, the all calculation before we calculate the shadow, before we calculate our shadows. So we have our color without shadows. But what is more interesting is that you can output almost anything. For example, have you wondered what is, for example, normals looks like? Because when we calculate in the light, we need to calculate our normals. And how it looks, we can see it. So we output in this case in buffer number 5, because the first one is 0, and we output our normals. Normals is vec3, so it free values here, and the last one is alpha, so alpha is equals 1. Where's our normals? And here's our normals. Here how our normals looks like. And you can output position. It's a color buffer number 1. Here, yeah. We calculate our position and output it. And position is not the color. So here, it's not about color. The red color is gives us the X position, RGB. Green is Y position, and blue Z position. So, for example, here is a clock for scene which is closer to us, is more bluish. The upper is more greenish, and the right is more reddish, a reddish color. For example, you can, I don't know, output. Okay, here's a nice example about shading. Sometimes, if you think about shadow, shadow is float. It's only one number. And of course, you can output shadow. Let me uncomment second buffer. And of course, you can output shadow here. It would be something like frog color 5 or 6. What was this? 6. Frog color 6 equals vec 4. For example, we have the same RGB value with our shadow. Our shadow is kept in this res value, and the alpha would be, I don't know, 0. So now if I use buffer select buffer select top, feed our first gel cell with all calculation here, and 6, right? So here's our shadows. But it's kind of, we have only 8 buffers, and it's not really a good idea to uh, pass a single value. I mean, uh, you could do it, but you can be smarter. You can be smarter, like you can, for example, here, frag color 2. Where is it? Where is it? Where is it? You can, because shadow is a float, you can put shadow in the first value of a color. In, let's say, shadow would be a red color. On the same buffer, we can also put the ambient occlusion as a green channel, and on the same buffer you can put, for example, fog. I don't really use the fog, but yeah, it's quite common in Raymarching to use a distance fog. It gives you more blurry, foggy colors in a distance. Some people like it, I don't, but if you like it, you can put the same code in any other components. Okay, so we have a fog in our third channel, and here we have the result. It's really messy, and then you can separate it channel by channel, for example by using the monochrome. You can separate, you can choose the only red channel, so it would be a shadow because we put our shadow in the red channel. On the green channel we put our ambient occlusion, and here's our fog. And then you can do some creative coloring and have some nice looking yellow shadow and pink ambient occlusion. Oh, yeah, it's yeah, it's Negate. Anyway, you can do whatever you want. You can do whatever you want. Another interesting thing is you can output, for example, distance. It's buffer number 5. Here. So I put our scene, our plane, noise, sphere, everything in 4 different channels of this buffer. And I really like how our noise second channel, noise the second channel. I really like how our noise is looking, and if you multiply it a bit, 5, and use lookup top, you have a really nice looking, like almost like Vincent van Gogh Starry Night looking thing. And do something with it and have this situation. And it opened up a lot of new possibilities, especially if you're not really good in GLSL, because of course you can do the same thing in GLSL itself, but if you're not a coder, like I'm not a coder, I learned GLSL for half a year now, so it's not that much, and for me using a TouchDesigner is much simpler. So I prefer to output everything I need as a buffers and then experiment it within our nodes. it's simpler from me. What else? What else? What else? And here is my favorite trick I found recently. Position. Here's our buffer with our position. It's here. Yeah, here we calculate our position from our camera and direction. Output it. And in a way, it's almost the same as a point cloud. And because it's a point cloud, you can do it whatever you do with point clouds. For example, in our palette, somewhere on the on the technique we have a connect point cloud. We can put it here. Let me enable camera again. Our camera movements. And in Connect Point Cloud, there is gel cell material that creates a point cloud from a Connect Point Cloud tops. But we can feed not a Connect, but our point cloud for Raymarching here. Let's look. We need to sample color our colors in null 2 and position mapping in null 1. So we can delete this, add in tops, connected tunnels, and here we can I think position is the first one, not sure. Okay, let's see. And the colors, and here we have our great point cloud from our Raymarching. How nice is that? And of course you can experiment with it. You can, for example, increase the point size. Well, maybe it's not. Like 3 is a good one. Nice, nice, nice. And also, because this is a position, let's add some noise to our position. Noise, and the second input out as well. Okay, it's too much. And it also, you need to set it like 32 bits. Yeah, it's too much noise. Width 0. Look at this. Nice. Oh, it's looking in one direction because we have monochrome noise, but here we have a really interesting thing, which would be kind of hard to achieve without Raymarching, or with Raymarching but without point clouds. And here we have our look. And of course you can feed this parameter from the music or from lip motion device or something else. So a lot of new possibilities. And of course you can explore some other image filters and everything. So explore it, put it in YouTube or Instagram or whatever. And if you found something really interesting, please share it, maybe tag me, because I also want to see what you will achieve with this trick. Okay. probably that's it from yeah, probably that's it. I remember one thing. Okay, let me put it off. Let me put it on. Shadow, shadow, shadow. Oh. No, no, no. No, no, no. Oh, yeah. It's just another trick I like, anyway. You can do something like anti-shadows, like white shadows, by setting the shadow for a value as minus. Not usually it's 1, but if you set it minus something, it would be anti-shadow. Let's call it this way. Okay. And the last one, it's not a part of a tutorial, it's a bonus. It's famous Indigo Keyless Raymarching template with different objects, with complex lighting, reflection, and everything. But I did only basic conversion to TouchDesigner, so I put on the mouse resolution and time. But here we have a nice code with a lot of comments. So if you want to understand it deeply, the remarching and the coloring, you can read this and read these comments, and I hope you understand them more about how it works. And if you want to understand even more, you can go to YouTube of Inigo Quiles himself. And recently he made 2 nice videos. One is a short one, he calls it Deriving SDF of a Box, where he explains, okay, let me pause it.
When using distant
The mathematics of Raymarching and how it works. So if you want to understand mathematics, you can watch this video. But the more interesting video is this. See almost 6 hours live shader coding, where he codes this
and switching on my live stream, and then people can enjoy and
where
they
is it?
can read what people
Where he
so
codes this jumping guy
experiment on
and
animation.
explains a lot about how to create geometry, how to create a complex lighting, complex coloring. It's 6 hours, but tons of information. Really recommend it. Really. Watch this. Watch this. So, probably that's it. Yeah, I think that's it. So, leave a comments. You can ask me questions. Subscribe to me in Instagram, on YouTube. If you like this tutorial, you can support me on my Patreon channel. And see you next time. Bye.